Hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. If you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to look into how we can write a validating admission controller from scratch. So there are chances that we will not be able to complete this in the single video. So we will be making two videos in which we will be writing a validating webhook controller from scratch. I have already created a video that explains what are admission controllers, what are the two types of admission controllers that we can write to extend Kubernetes. But in this particular series, in this particular video, we are just going to be writing validating admission controller. If we try to very briefly define what are validating webhook controllers, so whenever we make a request to API server, for example, let's say to create a pod. So if we run kubectl run nginx -- image nginx, it simply means that we are making a request to the API server to create a pod. So if there is a requirement, if we have a use case that this particular request that is being made to the API server should be intercepted by a component or should go through a particular phase, a particular validation, let's say. And that is the reason we would want to use validation admission controller. If we talk about a request to the API server, it can be any request. When we try to delete a pod, so for example, if we try to delete a pod, this particular request is also a request that can be handled using these admission controllers. And as I said, whenever we try to run something, either create, delete, patch, a request is made to API server, and that is the request that can be validated or can be mutated using these admission controllers. In this particular video, we are going to be just focusing on validating admission controller that is going to validate if we have created a resource, the resource that we have specified or the fields that we have specified in that resource are correct or not. So to understand that more clearly, let's look into one very small project that we have already built named Kluster. I have already created a playlist that explains what operators are and what this particular operator Kluster does. So let me very briefly try to explain what this cluster does. So let's say we have a test Kubernetes cluster that is set up using kind, let's say, and we want to create a Kubernetes cluster on DigitalOcean. So this is DigitalOcean, and we want to create a Kubernetes cluster here. So we have written an operator that is going to create a Kubernetes cluster on DigitalOcean for a cluster Kubernetes resource. So as soon as we create a cluster Kubernetes resource in here, let's say cluster operator is installed here, and as soon as we create the cluster resource, a respective Kubernetes cluster on DigitalOcean is going to be created. So this is, I'm just trying to set up a very basic understanding of the problem that we are going to resolve. So this is an operator that we have, let's say, up and running. While creating the cluster resource, we can specify size of the nodes that are going to be provisioned. We can also specify version of the Kubernetes cluster that we are going to provision. Now, let's say we have specified a version that is not actually supported by DigitalOcean. So in that case, our controller is actually going to make a request to DigitalOcean with this specified version. Let's say we have specified the version to be x.y.z, and this particular version is not supported by DigitalOcean. In that case, the cluster resource is going to be created on this cluster, and then the deployed operator is going to try to create the respective Kubernetes cluster on DigitalOcean, and then that call is going to fail because this particular version is not supported by DigitalOcean. So this is the problem that we have in hand. Now let's quickly go ahead and try to look into this particular problem. So I already have this operator up and running. So if we get all the pods from default namespace, okay, so we have the pod up and running, and if we try to look into the logs of this particular pod, and let's also go ahead and try to create a cluster resource. So and as soon as, again, if I'm just trying to explain the problem here. So if you don't understand this, I have a playlist that where I actually wrote the entire operator, showed it working, so you can refer to that video. So as soon as I create the resource here, so if you see cluster 0 was created, but we got a problem, and the problem is invalid version slug. So it simply means that the version that we have specified, so kubectl get cluster 0, so the version that we have specified here, this particular version does not actually exist or is not actually supported. So that is the reason the call to DigitalOcean API was failed. And if we, for example, want to look into the version that are supported by DigitalOcean, so these are the versions that are supported. And obviously we can see that this particular version is not supported. That is the reason this particular call failed. And this is where the admission controllers come into picture. This is where we can use specifically validating admission controller to handle this particular problem. So if we create a cluster resource, so we know that this operator that we have written, this operator responds to cluster type of resources. So if we see here, the kind of the resource that we created was cluster, and since our operator listens on or is interested on this kind of resources, it was able to do the things. Now what we can do is we can have, let's say, a component, a piece of code that is going to be responsible for, let's say, create request of this particular type. And as soon as a create request was created for this particular type, we are going to check if this particular version that has been specified in the resource is actually supported by DigitalOcean or not. And if the version that has been specified is not supported by DigitalOcean, in that case, we are not going to allow this request, creation of cluster resource request, to continue. And if we don't allow the creation of cluster resource to continue, the cluster resource will not even be created on the Kubernetes cluster. So in that case, our operator will not do anything, and which is expected. So we would just inform user that the version that you have specified is not correct, and the cluster resource will not actually be created on the cluster. So this is the use case of I would say, validating admission controller, and this is the piece of code, this is the piece, or this is the validating admission controller that we are going to write. So if we try to explain it a bit. So whenever we are going to create a cluster resource, we will have a validating admission controller running. So in the same Kubernetes cluster, we would have another, let's say, another service running. And as soon as a request to create this resource would be made to API server, that would be intercepted by our validation admission controller. And as soon as we got this particular request, we are going to check if the version that has been specified is supported by DigitalOcean or not. If not, we are not going to allow this request to continue further. We are going to send back the response that the version is not supported. So this is what we are going to do now. Now that we know what exactly it is that we are going to build, let's try to look into what are the components that we need to have in case of validating webhook controller. So first of all, we will have to have a server running, and this is the server that is going to handle the request when a particular resource is created. So let's say user wants to create a cluster resource, and as soon as the cluster resource is created, this particular request should be forwarded to our server that we have written. This is the admission controller that we are going to write, let's say. Now, so first of all, we will have to write this admission controller, and then we will have to expose it using a service. So we will have to deploy it on Kubernetes, and we will have to expose it using a service, and then we will have to inform Kubernetes API server that if there is a create request for cluster resource, in that case, that request should be forwarded to this admission controller. And that can be done using or by creating another Kubernetes resource called validating admission configuration. So as soon as we create this validating admission configuration resource and we specify that we are interested in create requests for this particular kind, when a user tries to create cluster resources, this request would be forwarded to our custom server, let's say, or admission controller, and then we would be able to check all the things that we want to. Now, the other thing that I wanted to talk about in detail is this server that we are going to write. So when we I have already talked about this when we talked about what are admission controllers, what are mutating and validating admission controllers. But let me very quickly try to explain a bit more details about this server that we are going to write. So when we configure a webhook using validating admission configuration, we also specify which particular service the request should be forwarded to. And when we specify the server, when we specify the service, we will have to make sure that the server is able to handle, or the server is exposed via HTTPS. So it's mandatory that this particular server supports HTTPS and not HTTP. If we don't have an application, if we have the admission controller that doesn't support HTTP, in that case, we will not be able to configure that in validating admission configuration. Even if we configure that and we create the cluster resource, API server is going to complain that the server is not serving HTTPS traffic. So this is very important, important piece that I wanted to talk about. Now, if we have to support HTTPS here, or our application that we are going to write, that application needs to serve as HTTPS, we will have to specify this particular application with certificate, TLS certificate, and key file. So these are the two things that we will have to specify: .crt and .key file. Once we have specified .crt and .key files, and we know that this application is running using this .crt and .key file, when we configure this service in validating admission controller, we can obviously specify the name of the service, namespace, and we will also have to specify the CA bundle, and this is the CRT file that we are going to specify in the client config when we specify the client in validating admission controller. So I hope this makes sense. So if I try to summarize this once again, we are going to create a validating admission configuration Kubernetes resource to instruct the API server that as soon as a create cluster resource or a create cluster request is sent to API server, instead of creating the clusters, forward that request to our admission controller. That admission controller must be HTTPS, and to make sure that our server is HTTPS, we will have to run HTTP server in our application, and we can specify custom certificate and key files to it, and the certificate file that we specify to our application, that is the certificate file we will have to also specify in validating admission controller for obviously this authentication to work. So I hope this makes sense. If I try to explain again how these things are going to be installed on Kubernetes. So we will create a deployment manifest where we are going to run this application of our that we just talked about, and we are also going to create a secret. That secret is going to have the .crt and .key file, and this secret is going to be mounted as a volume in this deployment, and this volume is going to be used in our application. So this is volume, and this is going to be mounted in our application. So our application is going to expect .crt and .key files, and those .crt and .key files are going to be provided using volume, and volume is going to be mounted on the applications. And when we configure the validating webhook configure, we can specify this .crt file in the client config, and we can refer to this particular service that is going to expose the deployment. So this is service, this is deployment, this is secret. So yeah, this is how things are going to look like once we are in Kubernetes cluster. So without discussing any other details, let's go ahead and try to actually write this server that we have been talking about. So let's create a directory named validation and controller. So our resource that our validation admission controller is going to respond to is cluster. That is the reason I'm using K here. And let's cd into that directory and open Visual Studio Code here. Okay. The other important thing that I wanted to talk about is, since this application that we are going to write, this application should be exposed, must be exposed via HTTPS. What we can do is, we also know that the API server in Kubernetes is also exposed via HTTPS. So we can use the same mechanism that is used there to expose our application. So if I try to explain, we know that API server is also exposed via HTTPS. So we can use the exact same mechanism to expose our application as well as HTTPS. So if we talk about the packages that are used to do that, so if you see here, in Certs.io API server package server, it simply says that package server contains the plumbing to create Kubernetes like API server command. And this is exactly what we have to do. We have to create Kubernetes like server that is going to be configured in validating admission controller. And we are also going to use another very relevant package, that is package server and options. So this application that we are going to write, this application should accept certificate, and again, this must be HTTPS, and this application should accept the cert and key file using flags. And like we talked here, these flags are going to be provided to the in our deployment file, using the path where we are mounting the volume, and this volume is going to refer to secret. So we will have to create an application that supports some options and some flags to specify the .crt and .key files. So let's just go ahead and try to do that. So first of all, I would import the options package. We know why do we want options package, because we want to support some default options to run our HTTPS server. For example, like I said, for example, flag to options to specify .crt and .key files, etc. So I know there should be something type secure serving options, and as you see here, we can specify all the things here. For example, bind address, bind port, etc, etc. So let's just go ahead and try to import this package, and we are going to create our own local struct, and this struct is just going to wrap the options dot secure serving options list. So this local struct that we have created is just going to wrap the options from upstream, so that if we want to add any other flag, we can try to do that as well. Let's go ahead and try to build this. We will not be able to build it because we have not even initialized a Go project. So let's just go ahead and try to initialize it. github.com. Okay. So function main is undeclared. All right, so we were successfully able to build the application, but it doesn't do anything as of now. So now that we have the option, I hope this makes sense. Why did we create this options? And once we have the options, let's just go ahead and try to create a function that would get us default value that we want for our options. So new default options is a function that returns options. So let's name it secure serving options. Okay, so here is the thing. We have initialized, we have a struct that has a field that has all these options by default, because obviously we need them. For example, server cert, uh, port, address, etc. And this can also be referred by looking at the upstream API server code. So that is the reason we are choosing this particular way to set up our HTTPS server. So right now we are not even writing the logic. We are just trying to set up our HTTPS server. So we want it to listen on the port 8443, and we also want to specify the pair name, and pair name is going to be, it should be string, I think, and it is going to be, let's say, a validation controller. And if we talk about why are we specifying the pair name, so for example, if we run this application and we don't specify the .crt and .key file, this particular package or mechanism that we are using, it is already automatically going to create self-signed certificates, and this is the name of those files that is going to be generated. So if we go to pair name, we can see here. So this is how it is going to be. This is how .crt and .key files are going to be generated if we don't specify them while running this application. But in our case, you don't have to worry about this, because we are going to specify .crt and .key file to this application manually. So now that we have default options, we should also support. So let's just go ahead and try to initialize it. So new default options, and we should also support some global flags, or this application that we are going to write, this server that we are going to write, this server should also support some global flags. For example, if you know, in any command line tool, when we specify --help, we get help about that particular client. So that is another thing that we would want to support. So let's just go ahead and try to create a flag set. We are going to use SPF 13. So SPF 13 flag. This is the library that we are going to use to create the to support the global flags, etc. So let's just go ahead and try to import it. Flag dot new flag set, and name is going to be, let's say, val hyphen controller, and error handling is going to be error on exit on a error, and this is going to be called flag set. And since we are going to use this quite a bit, let's have it as a const. So okay, now that we have options, we have flag set, let's add a hyphen help flag, so that someone can just run hyphen help to figure out what are all the things that are supported by this application. So to do that, we are going to use this particular module. So global flag dot add global flags, and this accepts the flag set. So we already have the flag set, and we can specify the name to be validating controller. And once we have all these flags, we created a flag set. We have specified a global flag. So global flag just adds help here. So if you see, we are trying to specify the help flag for our application. And once we have that, we have to add this flag set in our options. So the options that we support, we should be able to, or the options that are supported by secure serving options, we should append, let's say, these flag sets that we have defined in the flag of secure serving options. So let's go ahead and try to define a method here. So this is going to accept and o dot secure serving options dot add flags, and we are just going to pass the flag set that we have specified. So this field that we have used here, since upstream also uses SPF 13p flag, we are able to add the flag on the default options. So what we are going to do now is we are going to say options dot add flag set, and we can pass the flag set here. Now that we have set up the flag mechanism, let's go ahead and try to I have also written this helper thing here that I can see and write the code. So we have add the global flag, we have add the created flag set into the option, and we have to parse the flag set now. So fs dot parse, and we will have to specify all the arguments that are provided. And does this expect? Yeah, that's pretty much it. And this returns an error. So if error column equals to this and error is not equals to nil, in that case we are directly going to panic, but you can try to handle this this particular error. So I'm also going to summarize everything once I have written that. But yeah, feel free to reach out to me if you, for example, don't understand something from this particular example. So now that we have set up our options, let's say, now we have actually write the runtime configuration, let's say, using which this particular server is going to run. So to do that, like we have specified options or a wrapper around upstream options, let's go ahead and try to specify another config. And this is going to be called, let's say, secure serving config. And this is the part that is actually going to run the server. So we have to use this server package here, and let's go ahead and try to import it, and we are going to call it server dot secure serving info. And to initialize a config, again, these are the ways, or these were the code block that is going to be used to support the flags that we want to run the HTTPS server. But this is the struct that is going to be responsible to actually run the server, and that is the reason we are using this particular package here that says it can be used to create Kubernetes like API server commands. And if we look into secure serving info has a method called serve, and that method can actually be used Here we go. Serve. So this is the method that we are going to use on secure serving info to actually run our HTTPS server. So if you see here, it expects HTTP handler that we would be able to create very easily. This is time dot duration and then stop channel. So this channel, if this particular channel is closed, in that simply means that this server is going to stop. So we'll also have to create a channel and then pass that channel to this serve method. So this is what we are going to run eventually, but just to set up that particular thing, we have created config struct, and to return, for example, we have created a function to return default value of options. Similarly, we are going to write another method on options, and this is going to get us config. So this is going to return config, and so we can try to do this as well, but before that we will have to specify how do we exactly want to run the server. So for example, if certificates are not provided, do we want to default to self-signed certificates? So all those things are going to be specified here, and to do that, let me go ahead and try to look into how we do that. So o dot secure serving options dot maybe default with self-signed certificate. So like I said, if the certificate and key files are not provided, in that case self-signed certificates should be used, and that is the reason we are specifying this particular method here, and it expects string and so public address, alternate DNS, alternate IPs. We don't have to specify these things. We just have to specify public address, and public address can be, we can specify 0.0.0.0 because we don't want this application to listen on a specific IP, but this is going to be accessed by service name. So that is the reason we can specify this here, and we don't have to specify the other things, and it returns an error. So and if error is not equals to nil, in that case we would panic again. And once we have set maybe defaults with self-signed certificate, we'll have to initialize, or we'll have to add this particular configuration in the config that we have created. And to do that, what we can do is we have to call apply to, and apply to takes config and we can specify we have to apply those things in C. So we have to specify %c.secure serving config and return C. This should be okay. And let's go ahead and from main, let's go ahead and try to create the config. So C equals to options dot config, and now that we have the config, what we can do is we can, as we know, config has secure serving config, or let's call it info maybe. So, and secure serving info has a method dot serve, and that can be used to actually run the server. So let's go ahead and try to run that. So c dot secure serving info dot serve, and it expects HTTP handler. So let's go ahead and try to create the HTTP handler. So to do that, what we can do is, or we can use upstream as well, or standard library as well. So http dot new server serve marks, and this is going to be called, I'm looking at this side because I already have written the code, so I'm just trying to refer that. So mux dot handle, and we will have to specify the actual function that is going to be responsible to handle the things. So we are going to call it on, let's say, slash, and the function is going to be named serve cluster validation. And let's just go ahead and try to create this function. And this function must adhere to a particular signature. So let's go ahead and try to, so this should be the definition of the function. So we are just going to copy it, and this should be fine. Okay, and we have, we need to pass the handler, we need to pass the duration, we need to pass the channel. So let's very briefly talk about this particular method for once. So we need to pass a channel to this particular function that would, let's say, never be closed. So if you see here, it simply says that the actual server loop runs in Go routine, stoppable by closing stop ch. So this, it simply means that we should pass a channel that would never be closed, should only be closed if there is something, for example, if the application received sig term or sig kill signals. In that case, this channel should be closed, and if this channel is closed, this Go routine is going to be stopped. So we are going to create a channel like that, and we also have to specify handler. So to create the channel, again, we can use the utility from server, setup signal handler, and this returns, if we go here and look, this returns a channel, and uh, this is closed on either sig term or sig end, and this is what we want. Otherwise, the channel should not be closed, and we can pass this to uh, shutdown timeout. Let's say, let's keep it for now 30 seconds. So 30 into time dot uh, 30 into time dot second, and we can also specify stop channel. I'm going to explain all these things in some time again when we try to conclude it. So please don't worry about that. So this returns a channel and an error. So ch comma error if error is not equals to nil. In that case, we want to panic. And if we look into the implementation of serve, it simply says that it is being run in a Go routine. So as soon as we call serve here, this is not a blocking call. The main Go routine is going to finish. So what we can do is we can also try to listen on this channel, so that this call is this is actually going to block the main Go routine from completing. So our application is going to continuously listen on things. I think we have a very basic structure of our application up and running or completed. So let's just go ahead and try to test this. So fnp dot println, and we are going to write serve cluster validation was called. Again, I have seen that while passing mux, I have seen it in programming Kubernetes. We can wrap it in some logging abstractions, so that the output is going to be shown in a particular format. So if you want to do that, we can try to do that as well, or we can just pass mux. So we can just pass mux, but just to make it a bit better, we can do this as well. So handlers dot or let's keep it as it is right now, and let's go ahead and try to build it. So let's see. Okay, so we were able to build the binary, and if we run, for example, help, here we go. So this is the reason we have done all those things to make sure that our application supports all these options and flags. That is the reason we had to do all these things. For example, we used the packages that actual Kubernetes API server uses. The other step, the next step is going to be containerizing this particular application. So let's go ahead and try to create the Docker file. So from Alpine, and we are just going to copy validation controller to slash validation controller, and then we are going to specify the entry point to be val controller. This can obviously be improved, but we are just going to keep it as it is right now, just to show you how things are working, or how things are related to each other. So docker build -t, and we are going to name it val controller :0.1.0, and let's see. Okay, so the image has been built. If we try to run it, docker run -rmid, and if you see here, the self-signed certificate has been generated, and the reason is we have used a configuration that says if the certificates are not provided, use the self-signed certificates, and this is the reason why our application is running right now, but it's running using self-signed certificates. And those self-signed certificates, we don't actually need these self-signed certificates. That is the reason we are going to specify the self-signed certificates using the flags that our application supports, and all those flags can be looked into using -help. And if you see here, these are the flags that we are going to use to specify the cert and key file. So we have containerized the application. Let's go ahead and try to push this image. So to actually deploy these to actually deploy this application, we will have to also create all these manifests. So let's create a directory named manifests, and in there we will have to create the deployment file. So kubectl create deployment. In default namespace, image is going to be this image that we just pushed, and we don't want to actually create it. We want to generate the manifest deploy.yaml. Okay, we should be able to see deploy.yaml here. This is our application that is going to run. Now, if we go ahead and try to look into this particular diagram that we have here, we have our application, but we will have to mount the secret that contains .crt and .key files into this application. So first of all, we'll have to create the secret and then mount that into the deployment. So let's just go ahead and try to create the secret now. But even before creating the secret, we need the .crt and .key files. So let's create a directory named certs and cd into certs. And now we are going to use openSSL command to create the .crt and .key file. We have already talked about openSSL quite a few times when we talked about adding users to your Kubernetes cluster. So we are not going to discuss about it in lot more detail. But if I try to explain it very briefly, we are requesting certificate and key file. Validity is going to be 365 days, and subject can be used to specify the username and group for which this particular certificate is being created. So we are just going to specify username using cn, that is common name, and this is the service name that we are going to expose our application with. So if you look into this particular example, this is the deployment and this is the service that is going to expose that deployment. So we have to specify name of that service as common name here, and this is pretty much it. If we try to list all the things, we can see that the .crt and .key file has been created. So let's go ahead and try to create the secret now. We are going to name it certs, and we are going to create them from file. The name is going to be tls.key and tls.crt and tls.key. So a secret is going to be created with two data fields in it. The key is going to be name of the file, and value is going to be actually the content of the file. So dry run equals to client and generate YAML file and store it in secret.yaml. If we go ahead and try to look into the YAML now, the secret.yaml that we have generated, so we are able to see tls.crt and tls.key files here. Now, if we go ahead and try to look into this diagram again, we have created the secret, but we have to mount these secrets, and those mounted secrets should be should be passed to our application that is running. And we know that how we can pass these these certificates using the flags that we have added in our application. So first of all, let's just go ahead and try to, in our deploy.yaml, let's go ahead and try to mount the volumes. So we have talked about these things, so I'm not actually going to look into the official Kubernetes documentation to figure those things out. So I'm just going to specify the volumes, and inside volumes we are going to specify the name to be serving cert, and this volume is actually a secret, and name of the secret is cert. And we don't have to specify the namespace because secret must be in the same namespace where deployment is. Once we have specified the volume, we have to mount this volume inside the container. And to do that, we have to specify volume mounts. Again, I'm looking at my notes. So name is going to be the name of the volume, and it is going to be mounted on, let's say we can mount it wherever we want to, but let's say for now we want to mount it on this particular directory. So now what we have done is we have created the secret. This secret has been mounted in our container. Now all we have to do is we have to run this particular application by specifying the .crt and .key files that are present in this particular location. And to do that, we know that our application supports some arguments. So and we know that because we have specified all those arguments using the options, and we have also verified when we ran val controller -help, we were able to see that it supports all these arguments. So let's just go ahead and try to add those arguments. And the arguments that we are going to use is, first one is TLS cert file and TLS private key file. So TLS cert file is going to be this, and we know that there should be TLS key file as well. TLS private key file. And we know that these are going to be inside this directory where we have mounted the files. So this is going to be tls.crt, and this is going to be tls.key. And the other thing that I wanted to let's specify is verbosity. This is not very important, I would say, but let's just specify that. We can specify all these flags that are supported by our application, but we don't necessarily have to. And I think we are good. Let's go ahead and try to create this deployment. So kubectl create -f manifest and deploy.yaml, and kubectl get pods. We don't have to worry about this particular pod as of now. We are just interested in the validation controller pod. So it looks like it is being created. Let's just wait for a second for it to be created. And we are also going to create a service. So kubectl expose deployment. Name of the deployment is valcon, and we are going to specify the port to be 443 because we know that for HTTPS we use 443. We don't want to create the service, but we want to just generate the client manifest. And we should be able to see the service here. And target port is going to be 8443 because we have specified in our main.go that our application is running on 8443. So let's just go ahead and try to change this to 8443. So in our service, we'll have to specify services listening on 443, but the actual request is going to be forwarded to 8443 in our container pod. Okay, so kubectl describe pod, it's taking too much time, and the reason is the certificate secret is not present. So that is the reason the pod is not coming into running state. So let's just go ahead and create the certificate. So create -f certs and secret.yaml. Now we should get the pod up and running soon. This particular pod. So here we go. We see the pod to be running. So kubectl log, and we can see that now. If you see, it is not saying that the self-signed. So now it is not saying that self-signed certificates are being used. It is saying that these particular cert and key files are being used to run our application, and our controller is running successfully. Now what we have to do is, let's go ahead and try to create the service. So we have our validation controller deployment. We have also exposed it using a validation controller named service. The service is listening on port 443, but actually forwarding the request on 8443 of the pod. Now what we have to do is we have to, so if we look at this particular diagram, we have set up our application, our controller, it is being exposed via a service. Now all we have to do is we have to configure validation admission controller so that when we create a cluster resource, our application is going to be called. So let's go ahead and try to create that. I'm not going to explain the configuration manifest here, because I have already explained that in very great detail in one of the previous videos. So we are going to call it validation webhook.yaml, and I'm just going to copy this manifest that I have already prepared. So obviously we are going to create validating webhook configuration. The name is going to be clusters.api group. We have configured just one webhook here. The name is going to be this, and this is going to be respond to create operations of cluster resources from this API version. And again, I have explained all these things in great detail in one of the previous videos that I would link somewhere, so you can check that out. Now, client config is where we specify where our controller is actually running. Namespace is default in our case. So, and the service name is validation controller. So this also looks good. Now what we have to specify is CA bundle, and we know that the CA bundle is here. So this is what we have to specify in CA bundle, but encoded. So let's copy whatever we have in tls.crt and put that in webhook.yaml. And if we did the things right, we should be able to test this right now. So right now we should not be seeing any validating webhook configurations, but as soon as we create our validating webhook configuration, now we can see that one webhook is registered, and this is the name of the validating webhook configuration. Now, if we look into the logs of our pod and we try to create a cluster resource, so kubectl we have that resource somewhere else. Again, if you don't understand what this operator, what this project is, I have entire playlist written on this that explains what operators are and how did we write that operator. So create -f manifests, and we are just going to create. And if we see here, we are successfully able to intercept that request to API server. So we tried to create a cluster resource. So if you look into cluster one, it just specifies a cluster resource, and we just tried to create that. So create -f manifest cluster one, and when we created that resource, we were able to run our application. So if you see here, this is the log that we have specified in our main.go that says server cluster validation was called, and that is the message that we are able to see here. So yeah, we are going to look into this particular error message in the next video. I think this video is already too lengthy. So and this error, we are getting this particular error because the reason is, if you again remember my previous video where I explained admission controller, this piece of code that we have written, this admission controller that we have written, is going to be called with an object of type admission review. So admission review is the object using which this particular, so the request basically has a type, an object of type admission review, and we have to respond back with the same type of the object. And because we are not doing that, that is the reason we see this particular error. But in this particular video, I just wanted to show how we can configure an HTTPS server and how we can create all these Kubernetes manifests, so that when we create a particular resource, our code would be called. Now, let me try to explain it just one more time, maybe the code, and then we can talk about the architecture again. So if we talk about this particular application, our application must be HTTPS, or should be exposed via HTTPS, and we know a very great application, let's say, that is being served as HTTPS, and that is API server, and that is the reason we used the packages from API server to create or to expose our application as well, so that we would get all those options by default, the options that we were able to see when we ran -help on our application. And we have just a wrapper around the upstream options, and to actually specify the configurations using which we are going to run the server, we created a config struct that has secure serving info that actually that actually runs the HTTPS server. And yeah, I think this is pretty much it. And if you have any question, don't hesitate to reach out to me. In the next video, we are actually going to implement server cluster validation, where we would check, for example, if we have when we have created this cluster resource, we are actually going to check if the version that has been specified is supported by DigitalOcean or not. If it is supported, in that case, we are not going to return any error. But if it's not supported, in that case, we are going to respond with an error saying the version that you have specified is not supported by DigitalOcean. So all these things are going to be discussed in next video. But in this video, I would say, explain how all these things are plumbed together. So again, if I try to summarize things once again, what we have done is, we have created a very simple application, and that application is exposing some flags, and these flags are required to specify the CRT and .key files. And to expose these flags and to do other plumbing, we have used API server. How API server, Kubernetes API server does the things. And once we have written these applications, we tried to run it by specifying the certificate and key, and this certificate and key was specified to the deployment using a secret. So we created a secret. This secret had .crt and .key file, and this secret was mounted on the deployment. And once we have specified the volume, this volume was mounted in the application. And then we specified arguments, because we have created our applications in such a way that it supports arguments. And we have already seen that once we have the deployment, we were able to create the service, and this service listens on port 443, because we know that HTTPS is port 443. This redirects requests to the deployment or pod on 8443, because in our main.go we have specified the port to be 8443. And then eventually we have created another, let's say, resource, validating configuration. And this validating configuration specifies this particular service as client, specifying or presenting the certificate that we have used here, or this certificate that we used here is going to be used in client. So after that, when we try to create a cluster resource to API server looks at the validation configuration and redirects the request to our service, and that is where we are going to do all those things. The code that I have written, this code is going to be checked in or pushed into my GitHub repo. I would link that down in the description. Thank you so much for watching. If you think this is going to be useful to your friends, colleagues, classmates, share it with them. I'll see you in the next one. Thank you so much.